You are listening to an independent production. All additional audio elements were provided copyright-free and belong to their respective owners. For the ease of our listeners, this specific episode has been broken into two parts. You are currently listening to part 1. Good afternoon, everybody. Welcome back to another Gateway to Eden podcast. Today we are going to be talking about power and electrical generation, but before we do that, I want to plug the podcast again. We are on Spotify. You can check us out. And again, we're always on YouTube. I have a playlist going of everything. And then we still have the Discord. You can get that from my link tree in my bio. But let's get to the episode today. We are talking about power and electrical generation. And then we have
Zippity Zap Zap.
Zippity Zap Zap, something that I am intimately familiar with. And then we have a special guest today, Armitage. Say hello, Armitage.
Good morning, good afternoon, and good evening, wherever you may be.
Awesome. So Armitage, give us a little introduction about yourself. Where does your expertise come from? You made the presentation for us. Go ahead and tell us a little about yourself.
Well, first off, my name's Armitage. I am, where do I start? I had this all planned out and my brain said, nope, we're not doing that today.
I deal with that every time I go on the podcast, so yeah.
Every time. So my expertise, I've been working for 6 years on Texas electrical grid, specifically in I guess you could call it more of an analytical asset recovery type role. I have interfaced with every level of Texas's electrical grid, save for transmission, because they deal with the extremely high voltages and amperages, and that just doesn't sound like a good time to me. I'm also a college student, proud parent of two lovely little kiddos.
Awesome. So I guess I'm going to say go ahead and go through your little spiel with the presentation.
So this covers a presentation on power and electrical generation, which is looking to the future and community. Now, slide 2 is power discussion. What is power? Power is the electricity that's provided day to day at a nominal fee from generation. Powers everything in our homes, apartments, abodes, business, city, and state. Generally, what everybody is used to is the 120, 240 volt service with a maximum amperage cap of 200 amps. Now, for the more technical discussion, we can get into that later. But one of the specs on residential service is it's a 3-wire single-phase service with proper grounding, while businesses tend to run this and higher levels of voltage and amperage. Now, for the purposes of this discussion, we need to define what a grid is. So, does anybody have any questions on what a grid specifically is?
Not yet.
Awesome. So basically what a grid is a grid is everything connected from generation to your home. That's transformers, substations, generation, safety devices, even the power poles or conduit that those electrical wires are running through is considered a part of the grid. You also have power storage and what is known as power modulation installed on the grid to ensure reliable and steady access, steady usage of power to customers, which is all of us. Now, for the purposes of the community, a grid describes how we will interconnect various structures for power supply at a micro scale to provide power to the community. Everything making sense so far?
So far, yes.
Mm-hmm. All right, so the next slide we get into is specifically discussing power and residential supply. So there are generally 4 fields in any kind of grid environment. Those 4 fields are transmission, distribution, generation, and measurement. Now, for the purposes of the community, measurement is not going to be a huge deal. That's more commercial grids where they measure the actual usage that you use on a day-to-day basis through kilowatt hour and the demand that you pull, which is your kW. So for what we're talking about, measurement doesn't matter. These areas consist of generating the raw power and distributing power to substations that step down or step up that power to usable levels, which in the US ranges from the 120, 240 volt, 200 amp service to 12.4, 14.4, 4,000 amp and higher service, which is what you see with your, I guess you would call it industrial facilities. I know lots of oil field run huge pumps that require 4,000, 8,000 amps. The biggest concerns we have in generations, and this is where we go into primary concerns, generation will primarily be the concern because generation loss equals power loss. High voltage and near unlimited amperage presents an immediate hazard. Now,
Oh, yeah.
yeah, it's sparky and angry. Transformers and inverters do the same thing. So inverters bring 12 volt generation up to 120/240, and transformers bring primary raw power down to 120/240 or 240/480 or any variation there. In the US, most service for residential power is primarily 120/240 single phase service that provides a cap of 200 amps of power. Volts, and this is where we discuss the some of the more technical terms. So volts can be compared to water pressure. The higher the volts, the greater the pressure pushing electrons through the conducting material. So the higher your voltage, sharper your
The more
yes, excited electrons, as we were discussing prior, they move at light speed. So it's more pressure behind that. Now, amps are to electricity what gallons per minute are to water flow. So your gallons per minute is how much you're putting through. Ohms, which for the sake of materials is going to be another critical measurement. Ohms is the resistance provided by the material that we are conducting electrons through. It is essentially the governor on the engine of a 1973 Chevelle trying to run a race.
it is restriction to flow. Anything you try to do work with it sucks up amps.
I think the way it was explained
Yes.
to me is ohms can be thought of as like either a larger pipe that the water is going through or a smaller.
That is a great analogy. One of the analogies that I use to explain it is on a water filter kit that you hook into your water faucet at home. It comes with a flow restrictor. Ohms is the diameter of the flow restrictor that allows water to come through. So, any questions on this one?
No, I think we're good.
Not
there.
from me.
I'm not seeing any questions in the stream chat, so
Fantastic. Okay, so the next slide should be ready sources of power. And I imagine this is going to kick off a lot of discussion because there were four major types that I looked into. I looked into wind, solar, hydroelectric, and fueled generation. And I put some bullet points up here. So before we get into discussion, we'll kind of go through each one of these, if that's all right. So wind is very environment dependent. Now, I'm sure all of us have traveled around the country at one point or another, and there are areas that have a denser population of those massive windmills versus areas that are just have none. Now, most of these are going to be environment dependent, and they are going to depend on specific geological structures, but wind is going to require the ability to push the turbine of the windmill to generate power. Now, just looking on Amazon, it's cost effective. The problem with wind is there are high levels of downtime. Again, wind dependent. They can easily be mounted on mobile structures. It requires certain levels of wind to function. It also requires battery storage and monthly maintenance, such as oiling the turbine, making sure your fluids are level, so on and so forth.
Not including the possible breakage from overspeeding the thing.
Yes, the material which the blades are made of are absolutely going to be a concern because you can overspeed, overstress, and now all of a sudden you have a turbine tip flying off at Mach Jesus, which is not something we want.
Or worse yet, you grenade the transmission inside of it, and now you have a very expensive lawn ornament.
That is correct. Overspeeding the generator inside is absolutely a critical concern with wind, and that is something that will have to be monitored quite regularly via wind conditions, weather monitoring equipment, whatever have you. And we'll also have to be able to disable it in times of high wind, disconnect the transmission or whatever have you.
So that would basically mean we need somebody there monitoring weather conditions as a full-time job.
Or you could automate it. Unfortunately, the limitations of automation at a micro scale, I have not attempted to apply it just yet. So solar is going to be environmental dependent as well. We need high levels of sun for solar panels. It's kind of the mid-tier price range. It is reliable. It is very much sun dependent. As it notes here, it requires sunlight to function. It also requires battery storage. It also requires monthly cleaning and maintenance. And on top of that, it can also be damaged in areas that have a high presence of hail or damaging winds, anything that may potentially fall on it, because the the solar panels themselves are made of
Glass.
glass and silica. And it's very concerning to me on, okay, we have this, $200 to $500 panel here. What happens if something hits it and now it damages its ability to generate power? So that's something we would need to think about on the solar side of things.
So,
So,
I
sorry.
apologize, Armitage. My job before the one I'm currently doing was actually on a large-scale solar farm. Fun little story is involving both wind and solar generation is where I currently live is actually considered one of the top 10 windiest cities in the entirety of the US. So, you go out probably about 2 or 3 miles away from the city and there is this giant, I want to say 1,000-acre wind farm, but then we also have several different solar farms spotted around the place. And we actually ended up losing about 2 tables in I want to say 300 table setup of solar panels. Now, these aren't it's not 2 solar panels. No, these are 2 tables of 20 solar panels each that were just ravaged by the wind, because I was the assistant superintendent and the actual superintendent is from Kentucky. So he's not from here. He doesn't know how bad it gets up here. As far as I could tell, no one in the company really knew how bad it could get up here. And I'm just standing there like, hey, those are going to die. Those things are going to get screwed over. And funny enough, about a month after I left the site, we lost 2 tables there. And as far as I know, they still haven't been fixed, pardon me. And it's been like a year since I was on that site.
Yeah, there's a solar farm directly north of me that they ended up losing quite a bit of generation because of extremely high winds and damaging debris and things like that. I mean, that if you're not actively monitoring weather in the same aspect that you would be monitoring the wind side of things, I mean, that the potential for damage is incredibly high.
And also that they would be a little bit more susceptible to people just being general jackasses. I'm going to throw a rock at it.
Yeah, that is also another concern, which is why most of the facilities that I've seen have 8 to 12-foot fences around it with barbed wire.
Also, we have to worry about snow load up here, so a lot of the solar panels are usually rigid mount on a steep angle.
Yeah, snow was definitely a concern for us too. Fortunately, the tables actually rotated, so the panels were heated and the tables rotated, so the snow could actually be automatically melted off.
So around here, it's pretty common that usually you'll find like the solar farm, and then there's a skid steer with a giant squeegee stuck off the side, and they just drive down the panels.
Yeah, that is one of the most economical ways to do it. In dust high environments, they do it's like a hydro washer. They'll drive along, have it washed, and crew comes behind it with a bunch of squeegees.
We don't really have to deal with dust. We do have to deal with pollen in the spring. Those panels are going to turn green.
Very, very similar cleaning style between pollen and dust. The only concern with dust is because it's an aerosolized silicate. It does
It has more of an abrasive quality to it than pollen does.
Yes, abrasive, and it causes equipment fatigue, which is another one of the maintenance concerns, particularly when we discuss environments, the high dust or high wind, high pollen.
Dust gets heavy fast.
Yes.
Pollen can get heavy, but not quite as quick as dust.
Yes, and you don't have the abrasive qualities to worry about either, which is nice.
Yeah, but our biggest thing is, depending on where we go in the Northeast, is do we have a little amount of snow, or are those panels disappearing under a mountain?
Or a metric ton.
Well, like if we go to northern Vermont, there could be a few feet of snow. But if we go to southern Vermont, we could deal with maybe a foot. And it tends to snow early in the season and then late into the season.
So you could potentially have, 2 or 3 months of suppressed solar generation.
Or you're going in with a snow blower and
And
All
that's
of it.
including the rainy season in the spring and fall.
No, that's true. That is
Yeah.
true, because
I know they'll still work in overcast days and rainy days, but it is not working at peak efficiency.
Like, solar is still popular, but a lot of, like, the little farms around here, they also run hydro as, like, their main water source, because some days it's windy and a lot of days it's dead.
I am so glad you brought that up, because that brings us into the third ready source of power, hydroelectric. So this is what I was talking about earlier with the geographic formations. Hydroelectric requires a running water source. It is definitely cost effective and it is reliable at any time. This is the one caveat with hydro is you may need a hydro generation specific engineer for large scale generation, because if you pull too much water out of a river and you cycle it downstream, you could potentially end up losing the water pressure that you need to run your generation. Now, this one runs mid to
Not to
high price
mention
range.
the impacts as well.
Ecological impacts, yes. So the ecological impacts, we'll get into that here in just a minute, because all of these have some kind of ecological impact. Now, the price range on hydroelectric ranges from mid to high, and it depends on the specific generation needs of the community. Now, I will say that hydroelectric is noted to be one of the most environmentally friendly, provided you take precautions with the environment that you are working in, because no fish wants to go on a tilt-a-whirl through a high-speed turbine.
I want to go on a ride through a jet engine.
Yeah,
But
that
I
fish is
know.
becoming sushi if it does that.
Yep.
And as much as I love sushi, we probably don't want it in our electrical generation.
And
Usually-
I'm pretty sure tuna would not be a pleasant find in a hydro turbine.
I hope you're wondering where the tuna came from.
Yeah,
That-
I'd be more concerned where we found tuna.
That would be my concern. Why is there a tuna and why is it in freshwater?
Why is it this far north?
So for the last one on the ready sources of power, I did see a question. Yes, you would have to worry about high levels of smoke and soot. Bell Pepper 27 in the chat. Yes, you would have to worry about smoke with the solar and whatnot. So geothermal is kind of an off topic that we're gonna get into here in just a second. So fuel generation is the last ready source of power. The problem with it is it's loud, it's noisy, it's not environmentally friendly. It requires daily fueling or reservoir usage, and it requires daily or monthly maintenance. It causes exposure to carcinogens and toxic chemicals. Exhaust can cause a carbon monoxide risk. The benefit with fuel generation is it is easily portable at a smaller scale. Larger scale, it can be slightly difficult to move, but based on prior discussions we've had, you can mount generators on trailers, you can do things like that, so you still have some ease of portability there. It's when you get into the like coal turbines and using bituminous coal that it really does become a problem. Now, any questions on any of this?
What about steam generation?
So steam will require a heat source of some kind. So this goes into the geothermal.
What I've read, there's a reason we switched to bituminous and anthracite coal is it is so much more available and than wood, because you would need to basically deforest the entire property when you're going to buy to run it for a week.
That is absolutely correct. So bituminous coal is, I believe it's the higher BTUs of the two, correct me if I'm wrong, between bituminous and anthracite. But
I'm looking it up because I have to know. Anthracite is the higher burning, is the higher grade.
So I use bituminous for blacksmithing. Anthracite is, we would require a mine. We would require the infrastructure with the mine in order to sustain some kind of long-term steam generation using the anthracite coal. Now, the problem with this is this goes into fuel generation. So you have the coal plants, you have the natural gas plants, all of these things off-put gases and carcinogens and toxins and smog and things like that that we would need to look into before we did anything. Not to mention you have the ecological hazards. You have the issues that we experienced during the Industrial Revolution, because everything during the Industrial Revolution was fueled by coal.
Everything was belching smoke and soot and ash all over the place.
Yes, that is also one of the major contributions to the shortness of an Industrial Revolution lifespan, because you're breathing in all of that toxic smoke, smog. You were breathing that in constantly, and that resulted in respiratory issues. And I know for the community, we tend to focus more on the ecological side of things and long-term effects versus a short-term gain. So this is why fuel generation in general, in my mind, is kind of like, this is an emergency sort of thing.
I mean, we are going to rely on some sort of diesel and gas power generation for a long time, just because it's super portable, it's super handy.
Oh yeah, but like the large-scale coal and
we're
natural gas.
not going to look. Coal is not.
And I mean, we literally just, like last episode was literally about sustainability and longevity too. So when it comes to fuel generation, such as diesel electric, gasoline generators, and as you were talking about coal and such, those were always going to be the backups. And we're probably going to use them when we're first building everything before we can get the solar panels, the wind turbines, and the hydroelectric stuff up. But, beyond that, they're always going to be a backup because that's all we really need them for.
And the thing is, survivability and longevity depends on how many backup plans you have for the backup. If you've got one, you've got none, and so on and so forth. You've got A, B, C, D, E, F, G, so on and so forth, all the way.
One is none, two is one.
It's like, the only reason I bring up steam is if we do the greenhouses and stuff and we plan to run them in the winter, I suggested we get steam boilers to run for water heat.
That is actually not a terrible idea.
I'm popular and easy to run.
Steam boilers also provide the humidity you would need for the greenhouse itself.
Hey guys, I do have a quick question. If we were to go with fuel, would we have to get like EPA regulations and whatnot for the land? I know it's a backup, but that was one question.
I think, this is just off the top of my head, someone else may know more than me about this, but I think with that equipment would be purchased, so it should already have those regulations on it, unless we were like, mining out coal, as Armitage was just talking about. I don't think we need to worry about that too much, and I doubt we're going to be mining out coal in any capacity.
Good luck.
The only place we're going to be mining out coal is on Minecraft.
I mean, I'm game.
The community Minecraft server. I still need to get that up.
But I am hard against using coal.
No, understandable.
Yeah, I'd rather use wood. Wood is like one of the mainstays up here for boilers.
Wood is good for small scale stuff. If we're going to be relying on fuel, the odds are the least impactful would be propanes and natural gases.
Propane's easy to get, natural gas less common, but a lot of people run wood boiler heaters and generators up here because it's really easy to get trees.
LPG, propane, with the reliance that the United States has on oil and oil-based products, that should be readily available at most periods of time. However, looking into the economy and the way things are going there, from what I understand, we are definitely facing a gas, oil, so on and so forth crunch. So that's something to file away in the back of your mind.
Oh, yeah, I would drill, baby, drill.
I'm going to amend my answer to Raya's question a little bit because I just had a thought. Getting the generators that can run off of homemade diesel, are those going to be compliant? Are those going to have the same compliance with EPA regulations? I don't know.
This if we have an EPA in 3 or 4 years. So they did just do a massive deregulation.
I don't like that. I do not like that.
I'd be down for tier 4 diesel, even tier 4 biodiesel generation, because the thing with tier 4 diesel and the problems that come from it is a lot of start and stop use. When you go, okay, I need this on, I need it on for 12 hours at max RPM, then your DPF gets hot enough to regen and burn off all that soot, which is where like city use stuff and start-stop stuff just falls flat on its face.
Like,
With generators turn on and run for hours.
It's like if we're buying equipment for the co-op to use on property, I'm going to demand we buy pre-diesel emission, or else we're going to start running into expensive problems.
I mean, that is what I was thinking, like going off of GovPlanet and Doobie Brothers and such, we'd be getting the stuff that, can run on anything we want. right?
Oh yeah, and
Yeah.
worse, and if it's a diesel engine, you can modify it to run off of biodiesel.
Yeah, just
With a couple
finding
$100 investment.
biodiesel isn't always the easiest up here.
No, that's true. And the other reason I did not include geothermal in this discussion between generation and everything else is we have a lot of the same concerns with access to the materials we need to get the generation going. Like with what Broseph was saying about the Gulf Planet and Doobie Brothers, I mean, it's still kind of pricey. Correct me if I'm wrong on a lot of the generation that we would be able to immediately field, correct?
Vicro would know this better than I would.
Rephrase the question.
So it
He's
basically
asking about startup costs, essentially.
Oh,
yes.
so startup costs. So a lot of the price up here is going to depend on where you can get it, because like Vermont's a lot of wooded. It's a little more rural. Other than like say Brattleboro, Montpelier, which are the bigger towns and cities, we'd have to go to like Massachusetts, Connecticut, New York to get, the bigger solar panels, steam boilers. If we want to get like actual generators, we have to go down to like Massachusetts to one of the actual dealerships or something.
Yeah,
So that's
so
where like
there's
the auction yards are.
there's going to be a compounding cost to getting the materials that we would need
Yeah, we can get
to
wood, we can get steel in Vermont, but a lot of the complicated stuff you kind of have to go outside the state lines.
and so you'd have transportation, logistics, plus the cost of the equipment itself, which is another
Yeah.
reason why the
And because it's, Massachusetts is so expensive, we might save money driving the extra 2 hours to go to Connecticut or New York, where the taxes on auction yard stuff isn't as high.
that is true. That is true. And good luck finding a geothermal plant out there.
There is no such thing.
You're
Yep.
not going to find a used geothermal plant. You can find used diesel generators.
And that's one of the reasons why I didn't include geothermal in the ready sources of power, because it's going to be a very, very long setup time versus even a diesel.
And
Because you have-
also, geothermal is you kind of need specific geological formations just to do it.
And
And
how often
they're
are those
not
going to be
really
up in New England?
present in New England.
Yeah.
Exactly, and it's not like any of us are living on top of an active volcano.
Yeah, there's no real geothermal up here.
Hey, if we find a
you go-
random hot springs, there we go,
Awesome.
another tourist attraction.
Awesome.
So up here, you tend to see solar on top of mountains because we got big rolling hills.
Of course.
Wind, you won't find as much. Usually it's like a little farm that got a grant to put up a small windmill. Hydro is really freaking popular. Like you'll find a lot of hydro stuff. But that would mean we'd have to contact the Army Corps of Engineers and get engineering draws planned up and permits pulled for setting up a weir or something.
The requirements for the engineers are going to be the main stopgap with hydro.
Yeah. So a lot of people will look into the grid, or I think it's actually required here. And then they have solar, hydro, and a lot of people also run steam generation off of wood.
All right, so is everybody ready for the safety brief? for
Yes.
Electrical.
Oh boy.
All right,
Here we go.
slide 5.
Your fingers and stick them in the outlet, right?
Please do not do that. Oh my God. Don't touch the outlet. All right. So, hazards and concerns with electricity. The main hazards to be concerned about: fire. Electrical fires are difficult to extinguish because of the materials involved, the voltage, and burning liquefied metal. Electrocution. DC will not let go of you. AC might not let go of you. DC is direct current, AC is alternating current. Gassing material. Components may gas if overloaded, releasing toxic chemicals into the atmosphere.
The magic blue smoke.
Yep, stay out of it. Not fun.
If you see magic blue smoke, it has let the angry pixies no longer chooch, and everything is broken.
Exactly. Explosions. Arc flashes can reach 30,000 degrees Fahrenheit to 35,000 degrees Fahrenheit and are almost always fatal if the PPE fails or is not worn. And this is correct ANSI-rated PPE, also colloquially termed the B suit.
It has to be in date as well. If it's out of date, throw it out and get new ones.
Yes, and it's if it fails or it has so much as a little scratch, get rid of it. It's compromised. Projectile material. Arc flashes can create shrapnel and are exceedingly dangerous. There's a training hazard with this. Training is required to work on electrical components outside of step-down service because of the nature of the hazard. This is not a, oops, I screwed it up. It's you get one shot and that's it. Chemicals. Fuel generators and other components provide chemical hazards. PPE is definitely required. And whatever, if you don't pay attention to anything else, do not try to work with electricity alone and or without appropriate protection from hazards. We do not get a second chance with electricity. This has been impressed upon me since I began my career in the utility field, and it is something that has carried me so far through a good long time in this career.
The angry pixies do not care about you. They will bite. They will chew. They will not let go.
I don't know how much of my current audience knows this. I know I've shared it a few times on previous accounts, but I don't know if I've done this lore drop on my current account. I was just talking to Armitage about it before we started the stream, but if you... anyone who's been following me for a long period of time, you know that I used to be in the military. I was a nuclear electronics technician, and part of being a nuclear electronics technician is working with all of the electrical systems on the ship. And if you don't already know, I was working on an electrical system, a high-powered box, and someone flipped the wrong breaker, turning the box back on. And I am incredibly lucky to... I know Armitage said there are no second chances with electricity, but I am incredibly lucky to have gotten a second chance.
You had a buddy system in place,
Yes.
and that person was able to get you out of that terrible situation.
Yes.
And that is something I individually am thankful for. Otherwise, we wouldn't be here.
Me too. And I didn't say this before, but that's how I met Thor. That is how I met Thor. And he said, wow, that was crazy. Back you go.
This is like, nope, back to the plains with you. You've got more work to do.
Yes. Oh, I wonder if this is why he sent me back, doing stuff like this. I don't know why I
Hey.
didn't think about that before. But
Taking
yeah,
a run with it.
so
Now we
that
gotta
was-
get you black sunglasses and a suit so you can tell us you're on a mission from God.
Tell him you failed. Bang.
Mr. Anderson.
I was going more for Blues Brothers.
Aw, no Matrix.
I mean, I like the Matrix, but I was leaning more into the Blues Brothers.
We got
So-
a full tank of gas, half a pack of cigarettes. It's
100 miles to
160
Chicago.
miles.
It's night.
It's night and we're wearing sunglasses. Hit it. But yeah, during this entire specific slide, Armitage, you were actually sending me into some flashbacks back to my training days. Not bad
I'm
ones.
sorry.
Not bad ones. Not bad ones. I should specify. I'm just like, I'm looking at this, I'm listening to you, and I'm
I
like,
guess you
oh
could
yeah,
call
I
them-
remember my instructor screaming at us about that. That was fun. There's a good reason why he did that.
I guess
Yes.
you could call them arc flashbacks.
He actually did do a live demonstration of an arc flashback. They had a whole simulation set up to do that, and we got to go outside for the day and just watch the absolute chaos that comes from that.
Yes, and
It's
another
a
thing about
bundle.
those arc flashes is I've only had it happen to me once. I was working on a meter base for a customer, and there was something on the backside of that meter that had made contact face to ground. That meter went past my head at Mach Jesus and broke through their metal fence. Like it was a big deal, and it come to find out there's material stress because of the arc flash, the panel, and the meter container itself. I mean, it was one of those experiences that you're like, what happened here? I did everything right, and yet this still happened. So it's the sneaky traps that'll get you. And in that case, somebody had left a trap for me inadvertently when they were doing a reconnect and doing some maintenance on that meter base. There was a trap left there and by trap, I mean a situation that wasn't noticed that is hazardous.
The best
It ended
kind.
up turning into a big deal. Yep.
The best kind of trap.
But that resulted in replacement of the entire customer side system, as well as the replacement of our transformer because it overvoltaged the transformer and it blew through the safety mechanisms that were on that specific circuit. I think the
So-
final bill to fix everything was something like $45,000. Like it was not cheap. So, safety brief complete.
This was Episode 7, Part 1. You can listen to the rest of the episode in Part 2, coming up next.